Okay, we are working on the chapter 6.1 assignment, and let's see if it will work for me. All right. What do I need to do to set this up for elimination? How do I need to alter this? So I can multiply either the top or the bottom by -1. So if I multiply this by -1, then I get 3x minus y equals -8. And now the y's will eliminate. So I add straight up and down. And I get 10x equals -20. So x would be -2. Now I need to find the y. It doesn't matter what equation I plug that x back into. So I'll plug this into the top one. -3 times -2 is 6. So 6 plus y equals 8. Subtract the 6, and I get y equals 2. Okay. Now, I believe you have to get 3 correct in a row to pass off the objective. I think that's how it works. Okay. Let's look at another one. This one's already set up. The x's are already opposite of each other. So I can just add -2y equals -4. So y equals 2. Then I plug that 2 back in. X plus 16 is 23. Subtract the 16, and we get 7. So x is equal to 7. Okay. All right, let's look at the next type. So nothing is lined up. They're lined up, but it's not set up for elimination. What do I need to do to set it up for elimination? I could just double the bottom. So multiply the bottom by 2, and then the top and the bottom will be opposite of each other. So that would be 4x minus 10y equals -34. The x's cancel, and I get -19y is equal to -57. Divide by -19, and y is 3. And then I plug that 3 back in. We'll stick it in there. 2x minus 15 equals -17. Add the 15. 2x equals -2. So x is -1. Okay. Hopefully this is review. You've done this before. Let's look at another one. What should I do here? This one's a little bit more difficult. So this one's going to take 2 steps. One way to do it, times the top by 3, the top by 2, and the bottom by 3. And then the y's will both be 6's. One will be positive, one will be negative. Or I could times the top by 9 and the bottom by 5, but if you have a choice between big numbers and small numbers, I would pick small numbers. But it's going to work both ways. Do you want to see me solve this? Or do you guys understand it? You get it? Okay. Oh, I'm definitely taking this question out. Yeah, we're not doing that. That is not what I thought it was. Okay, a store is having a sale on jelly beans and almonds. For 6 pounds of jelly beans and 5 pounds of almonds, the total cost is $28. For 2 pounds of jelly beans and 3 pounds of almonds, the cost is $14. So, what do we not know? I do not know how many pounds of jelly beans I need, or sorry, how much a pound of jelly beans costs. And I don't know how much a pound of almonds costs. But I do know that 6 pounds of jelly beans plus 5 pounds of almonds, that's a Y, is $28. I also know that 2 pounds of jelly beans and 3 pounds of almonds is $14. What would you do here to set this up for elimination? I would times the bottom by, you could do the top by 3 and the bottom by -5, or you could just times the bottom by -3, and then the x's will eliminate. Okay. Here's something we haven't done before. Let's eliminate this first one. The x's cancel, the y's cancel, and I get 0 equals 0. Okay, but on the next one, the x's cancel and the y's cancel, and I get 0 equals 5. What does that mean? One of them is no solution, and the other one is infinite solutions. Which is which? Right. When is that a true statement? Anytime. 0 always equals 0. So if the variables cancel and you get 0 equals 0, the answer is infinite solutions. Okay? If you get 0 equals 5 or 1 equals 7 or any other non-true statement, then that is no solutions. Okay, and I guess it's entirely possible that you do one of these and it does have a solution. But if all the x's and all the y's cancel and you're left with something equals itself, then the answer is infinite solutions. If they cancel and you get something that's not true, then it has no solutions. Okay. Get to work.